Hello, everybody. Y'all come on in. Make sure y'all put y'all name in the chat. Today we're working on objective 10, which is to graph linear equations of the form ax plus by equals c using 3 points and using the x and the y intercept. All right. So the graph of a function is a graph of the ordered pairs x, y that belong to the function. Okay, so in order to graph the function, you have to find ordered pairs that belong to that function, and we're going to look at how to do that. Also, you need to know that a linear function is a function that can be written in the form f of x equals mx plus b or y equals mx plus b because its graph is a straight line. So right now we're only working with straight lines, okay? Over here, these are some important things you need to know about graphing. Here we have a vertical line and a horizontal line that meet, and where they meet, we call it the origin, that is 0. As we go from the origin to the right, this is the positive x direction. As we go from the origin to the left, that's the negative x direction. If we go up from the origin, that's our positive y direction. And if we go down from the origin, that's our negative y direction. So the vertical axis is the y-axis, all right? And the horizontal axis is the x-axis, okay? And that's going to be very important when we talk about our x and y intercepts, because those are on that particular axis. So the x-intercept is on the x-axis and the y-intercept is on the y-axis, all right? Also, you need to know the 4 quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, okay? And if something is in the quadrant 1, it will be a plus plus as far as the coordinates. The x will be positive and the y will be positive because you will have to go along the x-axis and then up the y-axis. So everything in this quadrant will have a positive x and a positive y. In the second quadrant, we will have a negative x and a positive y. In the third quadrant, we will have a negative negative, meaning we have to go a negative x coordinate and down a negative y coordinate. And for our fourth quadrant, it'll be a plus negative, meaning we will have to come over to the right for our x and then down for our y. So this is something very important that you guys need to know, remember, and completely understand as we get into graphing. So for our first example, we're going to look at, we're going to graph f of x equals negative 1/2 x plus 3. And the way that we do that, we want to find 3 points. So we're using -4, 0, and 2 for our 3 x values. So remember, previously I told you guys that the x is the input. So we're going to input these values for x. So when you guys are working, you're going to do this chart on your own. Here it's just already done for you so you can see what it looks like, okay? So you want to start with your 3x terms, okay? And when you have a fraction like the negative 1/2, you want to kind of choose numbers that's going to make that fraction go away. So you see I have -4 and 2. And of course, 0 is always a good one to plug in. So Those are the three that I chose. So the same way we have done before as far as with evaluating and all of that, we're just going to plug that term in for x. So everywhere where you see the x, we're going to plug that number in, okay? After we work it out, we get what our y equals. So we're plugging in the x and we're solving for y, and then we have our y term in this column. Then in order to have a coordinate, we have to have an x and a y. So over here we have our coordinates with the x and the y. So when we plot those 3 points, that's how we get the graph. So here we have -4, 5. So from our origin, we go to the left, -4, and then we go up +5, and we put a point there. Then we have 0, 3. So from our origin, the 0 represents where we go on the x-axis. So we can't go anywhere because it's 0. And so we just go up 3 and put a point there. Then we have 2, 2. So we go to the right 2 and up 2 and plot a point there. Then we connect it, and that is our line, okay? Because this is a straight line, we put an arrow at the end, the same way we put an arrow at the end of these, because it signifies that it's going to keep going on and on for forever. All right. And when you guys are doing this, please use graph paper and please use a ruler so that your lines are as straight as possible, so that when I am looking at your pictures, I can tell, if you fully understand how to plot the points and all of that. So this is what you guys are going to be doing as far as graphing using the 3 points. You will have to pick 3 x's, plug them into the equation, figure out the y, and then you will have your 3 coordinates to plot and connect for your graph of the function that's in question. All right, so let's get into some more examples. All right, so for example 2, we want to graph f of x equals -3/2x minus 3. So the numbers that we choose, we want them to, they don't necessarily have to, but it will help us in our calculations if the number is like a multiple of 2. That way we can, clear that denominator. So we're going to do 0, -2, and -4. When we plug the 0 in to our function, we get 0 minus 3, which is just -3. If we plug that -2 in, we get 3 minus 3, which is 0. And if we plug that -4 in, we get 6 minus 3, which is 3. So our 4 points, our 3 points are 0, -3, -2, 0, and -4, 3. All right. So when you're graphing, you want to start off with your vertical and your horizontal line. The horizontal line is the x-axis and the vertical line is the y-axis, okay? Of course, here in the center where they meet is the origin. Then you want to start marking out your spaces, and I recommend to use graph paper for this because it already has the little boxes. So each box on the graph paper will be a notch, and I will, kind of show you guys that as well. So over here, each notch is going to be 1. Over here, each notch is going to be 1, but it's going to be negative. As I go down, they're going to be negative. And as I go up, it's going to be positive. All right. So now we have to plot our points. So for the first point, we have 0, -3. So we always start from our origin. Whatever that first number is, that's what we go on the x-axis. So because it's 0, we don't go to the left or the right. We stay on the y-axis. And because the y value is -3, we stay on the y-axis and the x-axis at 0, and then we go down to -3. So this is where our first point goes. This is 0, -3. For our next point, we have -2, 0. So from our origin, we go to the left to -2, because remember -2 is our x, so we go from the origin over -2, and because our y term is 0, we cannot go up or down, so we just stay right here. So this is our point. So we got 0, -3. We got -2, 0. And I want you guys to write your point out as well. Same way I'm doing it here. Now we have -4, 3. So from our origin, we need to go to the left 4, because remember this is the negative axis. So we go -4, and then because our y is 3, we go up 3. So we go from the origin, left 4, up 3. So this one is -4, 3. Now all we have to do is connect our lines, and as you guys work on your graph paper, I want you to use a ruler so that your lines will be as straight as possible. And make sure you put an arrow on both ends, because that's what a line is. It's going to keep going. All right. So example 2, they asked us to graph f of x equals -3/2 x minus 3. And we did that by doing 3 points. Okay. So in order to do that, we have to pick 3 x's, preferably x's that are 0 and 2 multiples of our denominator, if we have a denominator. And we did 0, -2, and -4. We plugged those in for x, and we solved it for our 3 y's, and that's what made our coordinates. All right. Now let's look at example 3. Okay. Example 3, we are asked to graph y equals 2/3x. Same way, we're using the 3-point method. All right. So we have to pick 3 x's. Of course, 0 would be good, and we need 2 more that are preferably a multiple of the denominator, because we want to kind of cancel the denominator. It's kind of difficult to graph fractions, so that's why we want to keep it easier on ourselves, so that we can just graph the whole numbers, and we can do our little notches if you absolutely can't get your hands on any graph paper. All right. So we get 0, 3, and -3 because our denominator is 3. So when we plug 0 in, of course, y will be 0. When we plug in a positive 3, 3 over 3 is going to cancel. It's going to be 1. So we'll be left with the 2 in the numerator. And if we plug in negative 3 over 3 is going to be negative 1 times 2. We get negative 2. All right. So our coordinates will be 0, 0, 3, negative 2. 3, 2, and negative 3, negative 2. Okay? So if you do not have graph paper, your work will probably look like this, but it'll be, on the line paper. So try to space out your notches for each line. Of course, on the top and the bottom, that'll be easy. But on your ones on the side, you want to try to make it as close as possible. When we start finding the slope, not having graph paper might be an issue because finding the slope and all that is kind of very important to do that on graph paper. So if you don't have any graph paper, please do your best to get some, make some, whatever you got to do. All right, so first things first, do our X and our Y. And of course, we do our notches. To the right and up is positive. And to the left and down is negative. So our points, we have 0, 0, which that is simply just the origin. Then we have 3, 2, which means we need to go to the right 3 and up 2. All right. So this is 3, 2. Then we have negative 3, negative 2, which means we're going to go to the left 3 and down 2. So to the left 3 and down 2. And that's negative 3, negative 2. And we connect those 3 points. And that is the graph of y equals 2 over 3x. Now we're going to graph with the form ax plus by equals c. So with this form, we can change it to be in the form y equals mx plus b, and we're going to explore that first. And then we can use our x and y intercepts to graph it as well. So first, let's look at example 1. We need to write 4x minus 3y equals 6 in the form y equals mx plus b. The slope is m and the y-intercept is b. So in order to change this one, we need it to look like this one, where the y, no, this is not standard form. This is standard form. This is standard form and slope-intercept. All right. So in order to get this one to look like this one, we need the y on the left side by itself, and we need the x and the constant to be on the right side. Over here, we got the x and the y on the left side and the constant on the right side. So first things first, we need to move the x to the other side. So because we have a positive 4x, we need to subtract it. All right. So 4x minus 4x is 0. So on the left side, we have negative 3y. On the right side, we have negative 4x plus 6 because the 6 is positive. So it'll be a plus 6. Now, it still doesn't quite look like slope-intercept because slope-intercept has y equals, and we have this negative 3 over here. So we have to divide everything by negative 3. All right. So negative 3 over negative 3 is 1. So we have y. Negative 4 over negative 3 is positive 4 over 3. We still have our x, and 6 divided by negative 3 is negative 2. So we now have minus 2. So from here, after you change it to slope-intercept form, at this point you can graph it using slope-intercept form, which we don't actually teach in this objective, but you will see that in objective 11. Or you can do your 3 points, which is what we are demonstrating in this section. Okay? And remember, m, which in this case is 4 over 3. That's the m, which is also the slope. And the b, in this case, the b is negative 2. And the b is the y-intercept. Okay, so that's going to be important information to remember when we start graphing using the slope and the intercept. Okay, so for example 2, we're asked to graph 3x plus 2y equals 6. All right, so to do what we have previously been doing with the 3 points, we can basically just solve it for y, which is the same thing as getting it in that slope-intercept form. So we're going to subtract 3x on both sides. We got 2y equals negative 3x plus 6. Then we're going to divide everything by 2 because we want that y to be by itself. So we have y equals negative 3 over 2x plus 3. So if we do a table, because we have the denominator of 2, we can do 0, 2, and 4 because we want something that will cancel out that fraction. So if I plug a 0 in for x, all of this will be 0 and y will equal 3. So that gives us the point 0, 3. If I plug a 2 in for x, 2 over 2 will be 1, and we'll have negative 3 plus 3, which would be 0. If I plug a 4 in for x, 4 over 2 is 2 times negative 3, which would be negative 6 plus 3 will give us negative 3. All right. From here, now that we have our 3 points, we can graph it. All right. So on your graph paper, this is what you will do, of course, with the ruler. I'm just really throwing this on here for y'all. But from our origin, we'll do 0, 3. So that means we need to go at 0. We can't go to the left or the right. So at 0, we're just here. Then we go up 3. And this is the point 0, 3. All right. Then for our point 2, 0, we have to go from the origin over 2. And we can't go up or down because our y coordinate is 0. So we'll just be here at 2, 0. All right. Then for 4, negative 3, 4 being our x coordinate, so we go to the right 4. And then we go down 3. So this is 4, negative 3. All right. So we have our 3 points, and we can connect them together. And that is the graph. All right. For the next part, we're going to start going into the x and y intercepts. So y equals b is a horizontal line passing through the point with coordinates 0, b. So we have seen some of those, like this one, 0, 3. As you can see, it's on the y-axis. Graph of x equals a is a vertical line passing through the point with coordinates a, 0. So a 0 would be kind of like 2, 0, where it's on the x-axis. All right. So what we're saying is the same way 2, 0 is on the x-axis, the graph of x equals a means that a vertical line will go right through that point. So let's take a look at that. We're going to graph y plus 4 equals 0. Okay? So in order to graph this, we need to first solve for y. So we will subtract 4 on both sides, and we have y equals negative 4. Now we have y equals a number, so that lets us know that we're doing our graph of y equals b, which is a vertical line passing through the point with the coordinate 0, b. In this case, the coordinate is 0, negative 4. So when we graph that, we find that coordinate 0, negative 4, which will be here. And we do a horizontal line that passes through that point. Let's look at example 2. So we have x equals negative 4, and it looks like x equals a. So it's going to be a vertical line passing through the point with the coordinate a, 0. So a is negative 4. So we have negative 4, 0. That is our point that we're looking at. So we do our graph. And we need to find negative 4, 0. So that's negative 4 on the x-axis. And then we do a vertical line going through that at -4 on the x-axis. All right. So this is how you graph y equals b and x equals a. So now we're going to look at how to find the x and the y intercept. So first I need to do 3x plus 4, plug in a 0 for the y. That's going to give me 3x equals -12 and x equals -4. So this is our our x intercept. It's -4, 0. Then to find the y-intercept, I'm going to plug in a 0 for the x. So I have 4y equals -12, and y will be -3, which as a point, it will be 0, -3. To plot that, all I have to do is find those 2 points and connect them. So the first point, we got -4, 0. So from our origin, we go to the left 4, and we don't go up or down because our y is 0. So it's -4 on the x-axis because it's the x-intercept. Then for the y-intercept, it's 0, -3. So from the origin, we can't go to the left or right because the x is 0. So we just go down to the -3. So this is 0, -3, and this is -4, 0. Then we just connect these two, and that is our graph using the x and the y-intercept. So now let's do the same thing for example 2. We want to graph 3x minus 2y equals 6. We want to graph it using the x and y intercept. So when graphing with the x and y intercept, in my opinion, I think it's easier to just leave it in that form. Because when you plug in for 0, when you plug in the 0 for x and y, essentially you just kind of covering that up or covering that up. So if we plug in a 0 for y, we know that all of this is going to go away, and we're just looking at 3x equals 6. If we plug in a 0 for x, we know that all of this is going away, and we're just looking at -2y equals 6. So x equals 2 and y equals -3. So when we graph this, we find the 2 on our x-axis, and we find the -3 on our y-axis, and we connect them. That's how simple it is. So this is 0, -3, and this is 2, 0. All right. Any questions about graphing with the y-intercept? Well, the x and the y-intercepts. All right. For this one, we're going to graph. This is example 3. We're going to graph 4x minus y equals 4 using the x and the y intercept. So just to write out all the steps to make sure that everybody is clear, we want to plug in a 0 for the y, and we're going to plug in a 0 for the x. All right. So of course that's 0. So we have 4x equals 4. So x will be 1. Over here, of course, that's 0. So we have negative y equals 4. So y equals negative 4. As a point, this is 1, 0. And this is 0, negative 4. All right. When graphing it, we need to put a point at 0, negative 4, which is the negative 4 on the y-axis that I was thinking about earlier. And we have the 1 on the x-axis, which is right here. And we just connect those. And that is the graph. We got 1, 0, and 0, negative 4. All right, if you need to make an appointment with me for office hours, do not hesitate. A lot of you still have a lot of work that you guys need to do. So please get to working. So if y'all have a question, shoot me a text, and y'all have an awesome rest of your day.